Hey guys, what's up? Eddie Yahoo here with KissAnalog.com, and we have IMARS in the lab. We have this 3-in-1 device. You know, it's like a multimeter with the extra functions of an oscilloscope and a signal generator. So, you know, it's that old saying, jack of all trades, master of none. I mean, you know, we want to be at least a master of a multimeter, right? And then maybe offer some of those other things. But, you know, we want to see how good those other functions work, right? So we're going to come over to the bench. We're going to actually look at a switching waveform on a DC-DC converter, okay? This is a converter I have over here on the bench. So we're going to look at some waveforms and see how useful it really is. If it's just a gimmick or if it's really useful. I've used something like this out in the field before. I took it out with me and put it in my bag just in case I needed it. And one time I wanted to look at some voltages and I wanted to see the ripple and I wanted to see the inrush current. So I actually had a current probe on a little handheld guy and it actually worked really well. So, I mean, it's not a big screen or anything like that, but this one looks similar to the one I took out in the field. So let's check it out, see what we think of it, okay? It's an 80 megahertz scope and it's 200 megasamples per second, which that's about on par for 2-channel scope. 2-channel 80 meg, that's about right. So that sounds good. It also has the rechargeable battery, which is really nice. I think it has two 18650s in it. Those are nice sized batteries. That ought to be, you know, rechargeable batteries are great for something like this because, you know, something that does a lot of functions like this, especially a signal generator, could probably chew up some batteries. So those are good sized batteries. So first of all, they're probably gonna have some life to them, and so they'll last a little bit before you have to recharge. But then you can recharge them, not just have to replace them and throw the other ones in the trash. So that's a nice feature. Let's go over to the bench, take a look in the package, and let's start looking at some of these functions, okay? All right, guys, this is what the box looks like. Let's just spin around so you can see the back side. So the oscilloscope functions, 2 channels, 80 meg, 200 meg samples, and look, you got times 1, 10, and 100. So for high voltages, you can use 100x. You got auto, normal, and single for trigger, AC, DC, and ground. So edge trigger, 200 sets of waveforms for storage. So that's pretty nice. Built-in storage, right? Now the multimeter functions, it looks like it's a 6,000 count meter based on everything's on a 600, 60 number base. Frequencies, it can look up 10 megahertz. Okay. AC voltages up to 750 volts. And AC current, so up to 10 amps. Capacitance, up to 100 millifarads. That's impressive. Continuity. Okay, of course, we got a buzzer. And where's the signal generator? That's funny, they only showed to the functions on this. Okay, that's what the bottom of the meter looks like because it kind of wraps around the box. It says oscilloscope function. I still haven't seen anything about the generator on this. That's kind of funny, right? All right, so when you open up the box, it's a good sized meter. Look how long that is. I got pretty good sized hands, and that is a big meter. I thought I'd do a quick measure. It's like 7.5 meters long inside the bag there, and about a little bit more than 3.5 inches wide, and it's about 1 inch tall. Anyway, that's what I can see from the form factor. Let's go here. It's an IMARS, kind of quick print. Now, I did try that barcode, and I did get a manual, and I got a color version of the manual in here. So it did not provide extra information, just colorful. Okay, so I just opened this up, unfolded it. So look, scope operation, simple instruction sheet. So that's kind of a nice little feature. You can put it on the bench or whatever and see everything nice and large. And multimeter. And look, now we finally get to the signal source. And then it also talks about fuse replacement. All right, now this manual, look at that. It's fairly thick, and that's all English, okay? Okay, it starts off with some specs back here. Okay, I'll see if I can just page to this, just kind of show you what it looks like. So some pictures in there, like I said, the one that you get off the internet with that barcode gives you color version of this. And they kind of had a sticker on here. They covered something up to put a oscilloscope multimeter. So that's interesting. All right. Then the other thing is user's guide. Now they didn't check off what probe they put in this. I'm assuming, I would hope at least a P6100 since it's an 80 meg scope. But when I looked at the probe where the sticker usually goes on to identify which probe it is, it was not put on there. So I don't know what probe we got actually. I'm already kind of bummed a little bit because just one scope probe. It's a 2-channel scope. Okay, but I guess they could consider this a second channel. It'd be like a ×1 probe. That could also be needed for the generator, right? So yeah, so that's more of a generator cable, I would think. But I guess you could also use it as a scope, on the scope input. And then some test leads. Well, oh, whoa, actually, they're nice and soft. Okay, so the leads feel nice. Okay, I like those. Kind of a soft, rubbery texture on the side of the leads. Okay, so the leads are nice. All right, last thing, the USB to USB-C charge cable. Looks like a fairly long one, so that's also nice. Now, I've gotten cases like this before, these soft pouches, and this one is a big one. Let me pull the meter out. All right, guys, it's a nice touch. It's in a Ziploc plastic bag, kind of keep it dry. So there's the meter. You can see it is pretty good size. Let's measure that display. All right, so it's actually 2.5 if I go to the actual display. Okay, so yeah, that's 2.5 from corner to corner. So it's still a nice size display. Okay. Well, here, let's just turn it on for fun. Let's do that. Okay, I just pushed it and it turned right. I heard a little beep. Turned right on. Let's see what it looks like. Oh, that's cool. Comes up fairly fast. I've seen displays like this before, and I like them. I kind of think they're kind of different, and I think they're kind of fun. So they're easy to read. Now look at that. Because we're in voltage setting, see down here in the lower left, and up here it says install the, it says, up here it says install the leads in these 2 terminals. So that's kind of cool, right? The battery looks like it's fully charged, which is kind of interesting that they shipped it fully charged. So AC voltage, hertz, duty cycle, okay. Okay, if I push that button, now let's see, if I go to voltage, okay, it goes back to voltage and then all that stuff. But if I go to this button, then it gives me ohms, diode, and that's continuity and capacitor. Milliamps, okay, DC. And then I guess I push the arrows in this case. Wait, how do I get it over? Oh, I just push buttons underneath, of course. And so DC amps and AC amp. And look at this. When I go to, oh yeah, so it says use these 2 terminals. And still milliamps. So milliamps, those 2 terminals, amps, it goes, oh nope, use these 2. So yeah, see, I think that's kind of cool. Okay, and see, this says AWG, but it's really a signal generator or function generator. It does functions. It does square wave, ramp, and sine. Just square wave, ramp, and sine. And you notice on square, this 50% is not highlighted because you can't actually change it. So you can't do like a duty cycle on a square wave. I mean, it is a square wave with 50% duty cycle. So That's too bad you can't change that. Ramp, yeah, you can't change that either. So you can't get like a sawtooth out of the ramp. Sine, and obviously you can't change it for sine. That would expect. Frequency, okay, it looks like you just use these arrows to go around, change the frequency, and then come over here and say kilohertz, megahertz, and what would C be? Holy cow. And then you got okay and cancel. Okay, so as far as voltage goes, you got options of 0 volts, peak to peak, 0.1 volt, 0.2, 0.5, 1, 2, 3, and 5. Okay, so those are your options. So, okay, and then I would assume I just push channel 1 to go to scope mode, and wow, it does switch over very quick. So it's got a pretty fast response, right? You notice when I push buttons, it responds very quick. Now here's probe, okay, 10, 100. So it's also intuitive. I mean, it's easy. There's DC, AC coupling. Oh, ground. Let's go back to DC. Bandwidth. So it does have a bandwidth limit. That's cool. And then what's this? There's an arrow. Okay, position. Okay, so if I say position, I guess I can use these to move that up. Huh, that's interesting. Okay, otherwise, oh, you know what? Otherwise, it'd think I was changing the amplitude probably. Okay, so here, let's go back to channel 1 and go to the arrow. Vertical reset. Okay, so it drops it right down here. Horizontal reset. See that arrow up there? If I was moved over, wonder if I can do it while I'm here. Oh yeah, see, I can move it over with this, you know, left and right button. So I'm in position. I can move this up. So I moved it up a little bit, moved it over a little bit, and then I can go to channel 1. Guy, I wish I'd leave the menu up instead of dropping it, but okay. Oh my God, it's so fast to drop it, right? I wish it'd stay up there a little longer. Okay, reset, and then reset. So now it's here and there. Okay, at least it's intuitive. It's pretty it's actually pretty easy to get around this thing. Okay, so now what do? I go to channel 2. Now DC, okay, yeah, we've already gone through all this stuff. So what else can we do? Okay, there's trigger. Okay, trigger, channel 1, channel 2, rising, falling, mode, auto. Look, you can do single triggers, that's nice, and normal. So put it back to auto, and level. So if I'm going up, this arrow over here, I imagine it's going to go up with me. Boy, you have to hit a button a lot of times to get it to go up. But yeah, it's gone up the grid. So if I say reset, I had to do it quick before it, watch, it's going to go away in a second. Yep. I wish it stayed up a little bit longer because guy, you have to kind of be thinking. You have to kind of know what you're doing, or you're going to have to, yeah, you know what I'm saying. Beep. Okay, so utility gives me beep. If I hit enter, it says on or off. So right now it's on because we can hear it, right? So I'll go back, backlight. Okay, let's enter. Okay, let's go down to 5 and see how bright it gets. Okay, brightens up. That's plenty bright. I thought even setting 1 was bright. Okay, now I see it's a little dimmer. Okay, go to 3. I'll just maybe, yeah, I'll leave it at 3. Just so you can see kind of the middle grounds for now. Okay, let's go back here. Power off. Okay, we got 15-minute option, 30-minute option, 60-minute, and never. Let's say never. Okay, then what else? Let's go back this way. And yeah, so that's utility. That's everything on utility. Then we've done all these buttons. Now, if I just hit enter right now, what happens? Nothing. Okay. So if I want to change the voltage here and the time here. When I was in channel 1, and here, I'll show you. When I turned this position on, so the position is positioning the cursor, but you got to turn it off so that these can function as, voltage changes. So now I can go from down to 10 millivolts per division up to 10 millivolts. Now that's probably because it's on times 1. Yeah. So if I go, I'm going to put it on times 10. And then we'll go back. So now it's 100 volts per division. So it's kind of interesting because the down arrow means up in voltage. So I guess that means smaller, I don't know. And then up is lower. I would almost think that'd be backwards, and then this is your time. So if I go to the left, I go more time again, which I think's backwards. I think if I went right, I'd be getting more time. But I think they're looking at in the opposite. Like you want to zoom in, go to the right. You want to zoom in, go up, So, but yeah, that was just opposite of what I was thinking. Okay, down here we have an auto button. If I push that, it says auto setting. And if I had a signal, it would have probably tried to set up for the signal. Now, if I go down here and I go menu, hit the top of that button, then I get waveform. Okay, Okay, so these are waveforms that have been saved. Okay. So if I go back to menu, and if I come down to volts, okay, so I guess this is taking, saving the readings, measurements, I'm assuming. I'm going to go RMS. And then we'll go down time. I'll say, yeah, let's go down to, let's measure frequency. So I turn that one on. Inverts off. AI cursor. Not sure what that is. So let's go turn that on channel 1 for fun. Okay. And then there's calibrate mode. So we won't do that. But you know what? I recommend when you get a new meter, let it come to room temperature in the lab. Let it be on for probably 15 minutes and then calibrate it. So if it's been in your lab for a while, it's probably at room temperature. So when you turn it on, it's not going to draw a lot of power. So it's not going to heat up a lot. So you don't have to wait too long. But I'd give it a little time. Just make sure the temperatures are all stabilized before you calibrate. And then what else? Okay, so then go back to the menu again. Okay, that's menu on and off. Okay, let's just turn it off. Well, let's go to channel 1. Okay, so I see that I did turn on some measurements up here. It says RMS and then frequency. And there's no signal, so it's just waiting for something to happen. So I think we went through everything. Oh, there's a save. Let's go over here. Let's see what happens when we hit save. Okay, save successful. So I just saved on the waveforms. And then here's a stop and play. So, okay, so look at that. So cursor 1. So you're going to record these things and just come down here and turn that up back off again. So there we go. And yeah, just to run you through the screen, there's a trigger mode right here. It's set for 0 volts. It says rising edge right there. And then this is a diagram of what we see here on the waveform, what it's capturing. And then it says auto mode here. And then battery's fully charged. Channel 1, 200 millivolts. Channel 2, 10 millivolts. Time is 0 seconds. I think that's the trigger is up here at 0. So they're counting the middle and the 0 as 0, 0. And then time, 20 milliseconds. 20 milliseconds per division. So, yeah, pretty straightforward. Pretty simple. Pretty intuitive, I think. Don't you guys? Now, down here at the bottom, we do have the milliamp, the amps, the common, and the volt ohms. And one thing I want to point out, see this thing? Category 2, 1,000 volts. So, guys, that means like bench work, right? We're not going over to the breaker panel, which should be like category 3. We're not going to you know, the high voltage lighting that's between the main breaker panel and, you know, and the outlets. So that's all category 3. And outside is on the other side of the main breaker panel is category 4. So this is category 2. So category 1 and 2 is just stuff here at the bench. If I want to open up something and probe around on inside, even though it's 120 volts here in the US, or, you know, it's still considered category 2 because there's not a lot of energy, because there's a 15 amp breaker at the very least that's going to pop something. So there we go. Okay, now just to give you an idea of the case, it's a big case. On the side, this orange stuff is rubberized. Everything else is hard plastic. These buttons are all rubberized too. Okay, and let me see. It's all hard plastic back here. The kickstand, hard plastic. It's got a little bit of a flex in it, so you can flex it a little bit. But it's a nice stand. It's nice and square, so it's going to keep you solid, and it keeps it nice and upright, which I like that too. Yeah. And it looks like there's one screw to open up the case to get to the batteries. That's good. I guess we're going to do that. We got 4 screws back here to open it up. But you know what? Let's take some measurements before we open it up. I want to see how well this thing works, and then we'll open it up, take a look, okay? The other thing I want to show you is just on top. I almost forgot. We got channel 1, channel 2, and generator out. Now, this opening around here is pretty tight. These kind of handheld scopes, I found that, you know, it's kind of tricky to get your fingers down there and tighten them. So depending on what kind of scope probe BNC connections they have for getting your thumbs on them, you know, some are skinnier, longer than others. So we'll check them out. All right, guys, it looks like a nice probe, but the sticker, there wasn't a sticker applied right there, is where I think it would have been to identify which one of the probes it is, because I'm sure the maker of these makes them all the same. But yeah, it's got a nice hook on the end. This is what we call the witch's cap, right? Now I was going to try to pop it off, but yeah, there it goes. It popped off. Some of them screw on, but most pop off. And here's our ground strap. But it does come with all the attachments, a little spring clip and everything. So you can put the spring clip around on this thing so you can shorten your measurements if you really want to get that high frequency noise off. There's a nice positive click when I put this back on. Okay, guys, I'm going to pull this on so you can hear that. Did you hear that nice positive click? And then there's our compensation. So we'll have to compensate the probe the first time we use it, right? This probably should be done just on rare occasions, like, you know, with any kind of drift. Now, you know, the other thing is this ×1 ×10 probe, which I'm very happy. I like that. And it does have a nice positive click. So some of them, like on my Cyclone ones, they felt kind of mushy. And I always had to, you know, remind myself to just pull back when I used the probe, just make sure it didn't get pushed forward. But yeah, so this has a nice positive click. All right, guys. Now, see that little metal turret right there? It's just barely above the edge. So even my big fat fingers, I still had no problem, because some of them have the plastic covering this metal part, which makes it thicker. But that was actually not bad at all. Now, putting the second one on would probably be a little bit tougher. All right, guys, look how small these GAN fits are on this. So what I'm going to do is I'm going to reach over and touch this diode where we're going to see a switching node, okay? And I'll hold the probe right on that diode right there, which is a switching node, and we'll see some waveforms. And I'm going to try the automatic thing, just see how well that works. All right, guys, I think the thing just went off screen, so I think the power supply is up and running. I'm going to hit the auto button down here, see what happens. All right, guys, I was wrong. I had to turn up the voltage a little bit more to get it going. So that's why the auto didn't find it. Let's do the auto again. Oh, look at that. That's fast. And wow, that I'm actually happy with that. That's pretty cool. Let's make it a little bit bigger, and then we'll go to channel 1. And let's see, we got to go this way and say position. That's kind of a little bit of a pain, right? To move it. And it takes a lot of clicks. I'm pushing this button down here, trying to get it on the screen. Okay, there we go. Yeah, I mean, it's a big enough screen that you can get I mean, that's a readable display, right? So what is it saying? It's RMS 15.6 and frequency is about 517K. So that looks about right to me. Now, you know what? There's another thing I want to do. I want to go back to menu and I want to go down to volts, and I want to go to average because I saw another guy show average measurement that was way off. So let's just see if it is. There we go. So yeah, you have to turn off the menu and then it comes up. So average is 12, 13 volts, and RMS is, I think it says 15.5. So those are really small. I wish that was, you could make them a little bit bigger or something, but for my eyes, that's a little small. But yeah, it seems like the average is about right. So I think he might have had an AC coupled, and so that's why he was getting a really small reading. You have to have a DC coupled to get the right reading, because if you have a square wave or a sine wave with AC coupled, then the average is going to be close to 0, right? All right, guys, to compensate the probe, they don't have that extra little hook that usually compensate. So you go right into generator output. Okay, just tip the probe down there. And then, okay, guys, so the probe's up there. And then what we do is we just come down here and say auto and see if it captures the signal. But what signal is it going to capture? Boy, that puts a lot of waveforms in there, huh? That's kind of interesting. Let's go to AWG. And frequencies, it says sine wave. So what we want, let's go square wave, okay? 1 kilohertz, what we want, 3 volts peak to peak, that's fine. So let's just do that again. Let's come back to auto. Oh, maybe I gotta go back to scope function, go back to channel 1. Okay, now if you push the button twice, it turns off channel. If you're not using channel 2, just turn it off, hit it twice, turn it off. So channel 1, turn it back on. So let's go down here to auto. It's doing something. And the auto setting kind of bites, because, I mean, what is that? Come on. It should zoom in for us. I'm kind of curious. Okay, position's off, so that's not the problem. So I thought maybe I left position on. Okay, so then what we do is come down here, these arrows here, and see it was 100 milliseconds. So that's 50 milliseconds. It's probably like 1 millisecond is probably what we wanted. Okay, because 1 kilohertz, 1 millisecond, per division. So, and then it doesn't re-zero everything. That's kind of interesting. It doesn't, usually they go through and rechange your whole screen. So it's also kind of hard to read. It says 500 millivolts per division, RMS 1.5. I think decimal points are really hard to read on that little screen. Okay, so what I have to do is I have to come over to channel 1, go over here, say position on, so I can reposition my thing. And what I can do is just say reset, put it right here in the middle, and I'll say horizontal reset. So that would have moved it this way. So it's all in the middle. So that's probably good. Okay, and then come down here and hit okay, just have to wait, and then it goes off the screen. So now it's filling up the screen, and go channel 1. It's DC coupled. Okay. All right. RMS is about 1.5 and average is close to 0. So half the voltage is negative, half of it's positive. So the average is close. It says minus 55 millivolts. So now, you know what I probably should do is take this off. Okay. I'm going to remove the probes. We're going to calibrate. Let me get 2 hands on that. All right. So I took the probes off because you always, whenever you do the extra calibrations, you got to have the probes off. Just pretty much any scope I've done asks you to do that. So we'll go to menu and we'll use these arrows here to bring it down to calibrate. Then hit enter. And it says, please unplug USB and probe, then enter, press to continue. So if you got the charging going on, they want you to take that off too. Okay, so now I'm going to hit enter. And we'll see how long that takes. I'm going to leave the camera rolling just in case it's fast. I don't see anything happening, so I don't know if it's... I don't know what it's doing. So I'm going to push the enter keys, and maybe it'll ignore me if it's busy. No, it came up again. Please unplug the USB probe, then press enter to continue. Okay, enter. All right. I'm going to turn off the camera and wait a couple minutes to see if I hear or see anything happening. All right, guys, we're going to go ahead and plug the probe back in just to see what happens. All right, guys, I put the probes back in, and I didn't see it, still sitting there. So it either happened instantly or I don't know what happened. So I'm going to turn this, go back this way. Hit the menu button, see if I go, yep, menu button went away. And the measurement changed a little bit. Now it says minus 50 millivolts, 1.5 volts. So I don't know. Maybe something happened, but I thought it might set it down to, down to 0, but yeah, okay. Now the compensation, we want to see how flat the square wave is, right? So let's change the time a little bit more. Oh, you know what? I'm moving the waveform, so I got to go back to channel 1, go back to here and say position off, and then I have to go, and then I can go back to channel, whoops. Okay, let's go channel 1. Now I can spread things out. Okay, we'll wait until the menu disappears. And I actually have to move it over because this is sitting on top of my waveform, but actually I can see right there at the corner, and it's right there on the, see over here on this one, it's at the same level. So it looks like it's compensated, quite well. It looks like, and we can look at the bottom side of the waveform too. It's really flat. So I think the compensation looks good. Okay, guys, I got a nice high def Uni-T scope here, and I put the generator out of this into channel 3, and that's what I'm looking at here, and I'm measuring it. The average is it's jumped around 0.1, 0.7 microvolts and 1.49, 6 volts RMS. So it looks like it's pretty solid waveform out there, and looks pretty good. And it's measuring, I just want to show that the average should be 0 if it was perfect, because, we got part of the waveform up and down. If we did a DC offset, then we'd expect to see something else. Now the signal generator on it has 8 fixed voltage steps. So, it would have been nice to have a variable or something. Maybe that's not a big deal. It's just an extra bonus. It is like a function generator. It's not an ARB, right? It's fixed number of frequency types. Doesn't even allow you to change the duty cycle, which the fixed voltages aren't as bad as the duty cycle, because the square wave could be turned into a pulse wave. The triangle wave could be turned into a sawtooth. So yeah, that wasn't great, right? And then also the arrows, you can move the cursor up and down for the scope and back and forth, and the trigger as well. But you have to go through a bunch of menus to change that, so you can use the arrows for changing the time base or the voltage, the amplitude. So it'd be nice to, since we got all these function keys, just to use that, right, for time and trace. Okay, I want to move trace. I want to move my time and voltage. So that was probably the thing that bothered me the most, is just going through those menus, because you iterate. You end up going back and forth a lot. And then also the fact that when you go up, you just have to hit it a whole bunch of times. Now, I don't remember if I tried holding it down to see if it would just race up. Now I can't remember if I tried that. But yeah, it'd be nice to have a fine and a coarse adjustment. So you could go, you know, click, grid by grid, and then maybe a fine where you just go up the smaller grids, each one, something like that. So other than that, the screen is really nice. I like the display. It's a nice multimeter. It's a 6,000 count, just a general purpose. But for 6,000 count, you know, I don't know. I'm going to just say roughly $60 for a 6,000 count meter, unless you have a lot of extras, right? And so this price on this is, I think on sale, I believe it's like $85 or $90, something like that, which puts it right in line with the other 3-in-1 type handheld scopes. So it's hard to say. I think what I'm going to do is, I have a couple others. I think I'm going to do a shootout with all three of them so we can see them side by side. That'd be an easier way to say, you know, to kind of show people which one they might like best, maybe. Go back and watch all three of my videos over and over. They're kind of long, so I'll do a video like on a shootout like that, okay? The construction, everything seems to be nice on this. The two boards, I was actually impressed as... Oh, I'm getting ahead of myself. That's for the next video. All right, guys. Hey, thanks for watching. Sorry about the long video, and sorry for breaking it into two. Let me know if you want an hour-long video or 2 half-hour videos. I just want to get this out tomorrow, and then I'll post the next one the following day, I think. So I'll try to do that. All right. Hey, thanks for watching. See you next time.